Now, before we start talking about how to influence how swimmers move, we need to discuss why they choose to move the way they do. So, the traditional approach to learning and how movement occurs is that the brain is a computer and we need to program it with the correct skills. And we do that by repeating the same ideal movement pattern over and over and over again. And you get the expression that practice equals perfect performance. I mentioned this as a starting point as how many think that movement occurs. And now we're going to discuss a different way to think about things that's more useful and more applicable to what we want to accomplish as coaches. Instead, swimmers choose to move based upon constraints so that they choose the movements that are available to them. And if many movement options are available, they're going to choose what's easiest or habitual. And the more constrictions or the more constraints that are in place, the fewer options are available to them. They're also only going to choose movements that they're aware of. And so if we want to change how someone moves, we can place constraints to take away the movement options that they usually prefer. And then they're forced to find new ways to move, and then they become aware of them and they can start to use them. We'll go over some practical examples to help you understand what this looks like in practice. So first is the task constraint. So what a swimmer is trying to do is going to influence how they move. So for a certain task, there are only certain ways that someone can solve that task. For instance, if the goal is to swim a 50-meter freestyle or a 1500-meter freestyle as fast as possible, those are different task constraints. In one case, the 50 freestyle, there's no constraint on efficiency because the event is so short. However, there is a constraint on speed because the goal is to complete it as fast as possible. So swimmers are going to choose strategies that maximize speed without concern for efficiency. In contrast, in the 1500-meter freestyle, efficiency is a much bigger issue because of the length of the race. And so swimmers are going to choose strategies that favor efficiency over top speed because top speed isn't as important, but efficiency is more important. So a simple change in the task is going to change how swimmers move. And if you've ever watched a 50-meter freestyle and a 1500-meter freestyle, you'll see that swimmers choose very different versions of freestyle to accomplish that goal. Likewise, butterfly and breaststroke, there are different rules that govern what's legal in those strokes. And as such, swimmers are going to choose different strategies based upon those rules. Because breaststrokers can't recover their arms over the water, they have to choose a different type of recovery, whereas in butterfly, that constraint isn't present. And so swimmers will choose a recovery that reflects that lack of constraint. With increasing task constraints, we can remove movement options. So for instance, there are many different options if the goal is simply to swim across the pool. If the goal is to swim across the pool in 15 seconds, there's a lot less options. If the goal is to swim across the pool in 15 seconds and only take 12 strokes, there's even fewer options. If the goal is to swim across the pool in 15 seconds and take 12 strokes with a pull buoy, you can't use the legs anymore, so there's even fewer movement options. Lastly, if your goal is to swim across the pool in 15 seconds and take 12 strokes with a pull buoy and hold upside down paddles, there's even less options that will successfully allow for the completion of the task. So in this way, by increasing the task constraints, we can shape how swimmers choose to move. By removing options, we can push them towards a given solution. So what's the value of using task constraints? As I just mentioned, we can force swimmers to change how they swim by placing task constraints that remove options that they would otherwise choose. And best of all, doing so doesn't require instruction. As you saw in the last example, as I changed different task constraints, swimmers are going to have to swim differently, and in that case, be more effective with applying propulsion with their upper body. Something to think about. What happens when you give the exact same task to your entire team? You get different results. And what does that mean? It means that the individual acts as a constraint as well, and so what the individual brings to a given task is going to influence how they move. We'll talk about why that's important next time.